Hey guys, welcome to question FM 260 of the Further Maths Fortify Study Guide. This question reads, which one of the following statements about critical paths is true? So option A says if there is only one critical path in a project, then reducing the time of any activity on that path will reduce the minimum completion time for the project. So straight off the bat, this option actually seems fairly sound. Particularly because they've mentioned that if there is only one path in a project, then reducing the time of any activity on that path will reduce the minimum completion time for the project. So the only time that wouldn't be true is if there were two critical paths. So for example, just to do a nice simple one here, if we were to have some vertices like that, and our network for our project looks like this, if these were both critical paths, so this being one critical path, this being another critical path, if we were to reduce one of these two, that would just knock that off as a critical path and we'd still have the same completion time. So if we're only looking at one critical path, reducing anything on that path will actually give us a reduction in the total time of completion. So A is looking pretty sound from the start. B says a critical path always contains the path with the most activities. This is incorrect because a critical path is just the path that contains the most time. So it's the path that takes the longest to complete, which is what makes it the critical path, because everything else is able to move ahead, and what we're waiting on are the activities at along the critical path. Option C says there cannot be two critical paths in a project. This is also incorrect because if two paths through a project are both the longest, then we will have two critical paths. Option D says the critical path cannot contain the activity of the shortest time to complete. This is also incorrect, as well, of course it can, as long as that activity is in the path that contains all the other activities that end up adding to be the longest. We can have a path that contains the activity with the shortest time to complete in there. E then says no amount of increase or decrease in time can change the activity order of the critical path. This is also not true because as we change the times of activities, we can change which activities are along the critical path. So just to go back to our little example before, I might put some numbers in here this time, just to make it a little bit more accessible. So I thought this explanation might be a little better if we had an actual drawing to go off. So looking at this network here, so maybe I should put some arrows in. Our critical path can be found along this path here, so the 3 and the 9 and the 2, because 3 and 9 make 12, 5 and 6 make 11, so this is going to be the longer path, hence our critical path. So all in the system, we've got 12 and then 2, which means it's going to take 14 of whatever unit we're using here. However, if we were to look at activity 9 and reduce the time it took to complete activity 9 to 7, that would now make this part of our path here worth 10, and that is smaller than our 11, which means our critical path would now move along the 5 and the 6 before hitting the 2. So A was our correct answer. If you guys have any questions for us, please drop them in the comments below. Otherwise, I'll see you in the next video.